Welcome back. This video will finish our second PowerPoint for Unit 5. And basically, we're going to go back and grab one more example problem for us to look at. And I'm going to share a PowerPoint set here that has the problem in. We'll attack the notion of objective function, build some constraints, and set up our solution opportunities. Then we'll bounce over to Solver, and we'll try to find out what kind of an answer we can get for our second and final example. So with no further ado, let me pop over to this PowerPoint and share it with you. All right, from the beginning. All right, first of all, I tried to tell you this when we were in the last video, and I'm not sure it came across very well, so I put a slide in here. This is the reference point for that last problem where we were in Excel, and I don't want any confusion in terms of where you actually locate your solver capabilities once you've opened Excel. On the laptop that I'm using to shoot these videos, apparently when I added solver, it put it on my data tab. So if you look at the ribbon across the top, you can see that data has been selected, and all the way to the extreme right out here is solver. And once you click on that, you'll see the opportunity to identify what cell houses the value for your objective function, what cells house the variables for your particular constraint set, where your constraints are, and then the options to go ahead and run the actual linear programming with Solver. So we'll do it again with second example, get you a chance to think about some things, and then we'll bounce back over to Excel and see if we can make a solution happen for our second example. For the example that we finished on a previous video out to Excel, we had Sparky and Sally doing some productions of some flyers and some packets of brochures, and we went ahead and found some. We built an objective function. We identified some constraints, and the solution that we found in Excel with the aid of Solver was they should make 12 packs of flyers, 16 packs of brochures, and that would in fact maximize their profit at $440. And those are the values that we found by use of Excel on that first example. Here is example 2 as we move through one more shot. And this time you're going to go on the road and you're going to sell some Deadhead merchandise because apparently you're a big Grateful Dead fan. I have to tell you, my last roommate when I was in college was a gigantic Deadhead, and I had not a lot of experience. But man, that's all he listens to. So those people are into it. So look, I know there are a lot of words on this screen and it's difficult to read. So I'll just shut up for a minute, have a sip of coffee, and you can go ahead and read the screen and figure out what it is that identifies as constraint as we approach this thing. We're going to make some profit selling some dead merchandise. All right, it looks like at some point in time, we're going to have to identify how many sweatshirts we're going to make, how many t-shirts we're going to make. So those are probably good candidates for our variables. And then we'll have to identify some constraints. The objective function seems like it wants to talk about profit, so that one shouldn't be too hard for us to build. So let's go ahead and begin this thing and see what we've got. Again, a lot of words in the text box. Let's see what we can pull out. So I've decided for our purposes in this example that we'll let X represent the number of t-shirts sold and Y will represent the number of sweatshirts as we go through the problem. So, all right, we got two things to identify, and now we have to figure out what it is in the problem that constrains us as we get ready to load up our VW van and head out with the dead. Okay, so objective function time, we want to maximize our profit. We know that we make $25 profit for every t-shirt that we sell, and we make $15 profit for every sweatshirt. So if we come back to those variables that we represented on that previous screen, and we let X play t-shirts and we let Y play sweatshirts, that's pretty clean for us for objective function. Our profit, P for profit, very clever, I thought, 25 bucks for each t-shirt in addition to 15 bucks for every sweatshirt. So again, that's probably not that hard for us to pull out of all of those words. So we're good to go with the objective function. Time to turn our attention towards constraints. All right, so let's see what we got. Man, again, a lot of words in that text box. I pulled some ideas out for us. All right, we're going to have to talk about time. All right, each day of the 4 days that we're willing to work before we launch, we're willing to work for 14 hours. All right, now be careful, that's 14 hours each day over a 4-day span. So that's actually 56 hours. It takes 30 minutes for us to make a t-shirt, takes 15 minutes for us to make a sweatshirt. Be careful, you got hours and minutes hanging out there. We're gonna have to be careful. All right, another constraint has to do with space. The van only has 40 cubic feet of space that we cannot exceed. And we happen to know that it takes 0.2 cubic feet for each t-shirt that we're going to pack. And it takes 0.5 cubic feet for each sweatshirt that we're going to pack. And I put on the bottom there that we should make sure that we understand that neither X nor Y can be negative. All right, we either have some t-shirts or we don't. We either have some sweatshirts or we don't. There's no such animal as -5 t-shirts. So our last two constraints might just say X is greater than or equal to 0, Y is greater than or equal to 0. As we saw in Solver, there's a click box for us to just say, hey, we're going to indicate that we don't want any negative possible values for X and Y. So that's not too bad for us. We don't really need to set up a left side, right side for those two constraints. All right, it's time for constraint time. All right, watch out. Here we go. X tracking, oh, I'm sorry, that's a mistake by me. X should be tracking t-shirts. Y should be tracking sweatshirts. I'll edit that before we post this thing in, but for this video, we're just going to keep on going. X references t-shirts, Y references sweatshirts. All right, what do we got? Well, in terms of 30 minutes for each t-shirt, 15 minutes for each sweatshirt, and that 3360, if you're saying, where did it sneak in? Well, remember, we had 4 days at 14 hours a day. That's 56 hours that we're willing to devote, and each of those hours is worth 60 minutes. So we're running straight out to minutes on that first constraint. 30x plus 15y is less than or equal to 3360. That's a minute play. Second of those constraints that you see says space. It's all about space. It's going to take 0.2 of a cubic foot for each t-shirt. It's going to take 0.5 of a cubic foot for each sweatshirt. And the total amount of space can't exceed 40 cubic feet. And those last two, X and Y, can't be negative. I didn't go ahead and include, but they would be constraints that we'll just indicate in Solver as we get good to go. So there are our constraints. This time we've got 4, but 2 of them are kind of implicit in the fact that we don't want a negative amount of t-shirts or sweatshirts. So what we're going to do is we're going to head back over to Excel. We'll fire one more Solver approach. We'll see what kind of values we get out of this. I'll probably just wrap down Unit 5 by looking at the Excel video. All right, you will find that as we get ready to do our exam, a summary coming in here. So when we get to Excel, we already know now what our answers are going to be. We should get 90 t-shirts. We should get 44 sweatshirts, and that gets us a pretty hefty profit of $3,130. Assignments as we head over. Well, Excel takes a bit of getting used to in terms of Solver. You're going to have to play around with it. The sheets that are included in the sample file in the resource folder give you that already set up look. So you can get in there and you can see what this does in terms of some product. I've already taken the liberty of setting them up for us. Please make sure that you have a chance to play around with it. You can create some things, and you should probably try solving some of the problems later on with Solver to make sure you get some experience with it. Wrapping out Unit 5, there are no book problems to do. So in the resource folder, you'll find that there are 2 stack assignments that you shouldn't have a whole lot of trouble with. One simply does the notion of systems of inequalities and gets you a foot start into the idea of graphing. And we may have maybe one where you have to graph. And there are some others where we just have components of the process of linear programming for you to practice with. Again, that should all be in. If you have issues, if you have concerns, send me an email. If Excel causes an issue and Solver doesn't seem to be working well for you, again, an email away helps things. All right, I'm going to head on over to Excel and we'll take a look at a solution to that second example, and that will wrap us out for Unit 5. See you there.